Good morning, everyone. Welcome to TMLS ML in Finance 2021. My name is Mamta Gupta. I have done my master's in AI from Queen's University and currently working as Senior BI Engineer with Sonder in their data and analytics practice. Today, I have with me here is Dean Van Asseldonk. Dean has been working at a FinTech startup, Borrowell, as a data science manager for past 4 years. His work focuses on recommender systems and personalization for financial product and content. He has done his bachelor in mathematics from University of Waterloo. In his spare time, Dean enjoys downhill skiing and the tribulations of shard of bread making. Now I will hand over to Dean for his presentation. You can ask any question in the chat here and Dean will be answering it at the end. Over to you, Dean.
Thank you, Mamta, and good morning, everyone. Hope everyone's morning is going well. Hope everyone's March Madness brackets are going well. I'm really excited to be presenting today about Future Store best practices at FinTech startup Borrowell. And I've got a bunch of stuff to cover, so I'll just hop right into things. All right, so my name is Dean Van Asseldonk, and that photo on the left there is a bit outdated. I've grown out some pandemic hair over the past year and a half, so I may need to update my LinkedIn photo, but I'm a data science manager at Borrowell. I've been with Borrowell for just over 4 years. All right, so for the agenda for today, I'll give everyone an intro about Borrowell, about the company, as well as the data products that we have both in production and in development. And then I'll hop into an overview of our Future Store that we've been working on. And the second kind of component there is the kind of key considerations that we've found in our experiences building out our Future Store that I wanted to share here. And I'll kind of go into depth in all of those kind of 6 categories. And then towards the end, I'll talk about where we're looking to go next with our Future Store at Borrowell, as well as how all of you can get started, either building a Future Store from the ground up or continuing to build on an already existing Future Store at your organization. And then really hoping to get to all of your questions at the end. So feel free to post your question in the chat as I go through the slides, and really hoping to get to all those at the end. All right. So about Borrowell. Borrowell is a financial services marketplace. We connect our users who sign up to get their free credit score and free credit report with a number of different financial products shown on the right there. So we're really a marketplace. We have 1.8 million users on the platform today. And we're a Canadian FinTech company. We're based out of Toronto. So that's a kind of a quick story for us. And the data products that we have in production at Borrowell vary. We have kind of 4 main products in production today. The first 3 there are real-time prediction systems, while the 4th, user segmentation, is a batch updating system. I talked a bit about how we kind of recommend financial products to our user base. Kind of a key product we have is our recommender system, which identifies which of all of these financial products across these many different kind of verticals or categories of financial products are relevant and are eligible to our 1.8 million user base. And that eligibility component is really important and has motivated us to build kind of this second data product we called Approval Chance, which estimates the likelihood a user will be approved for a credit product if they were to apply. And third, predictive bill tracking. We kind of forecast bill payments, and we use the system within the bill tracking feature in our mobile app with Borrowell. And lastly, user segmentation is mainly used to identify personas. So we've taken all the different attributes about our users and applied a dimensionality reduction to reduce these dimensions down to kind of 4 key dimensions. And within this 4-dimensional space, We have these highly concentrated clusters of different user groups, which help us identify personas. I'll be talking a bit more about these 4 dimensions, specifically one of the 4 dimensions later on in the presentation. And we currently have also 3 data products currently in development. These are our email response system, our churn prediction model, and our content personalization system. So across the 4 data products we have in production, as well as 3 in development, this is one of the motivations for our machine learning feature store to really help support all the different data products that we are currently working on. All right, so to give an overview of our feature store, the motivations of it, and the architecture of it, I'll jump into that. So, I'm sure you all know, what is a machine learning feature store? We view it as a centralized data set of curated features or curated inputs used in a machine learning model in the model development. And these features can be used, shared, and maintained. For us, for our approval chance data product, the credit score of a user is quite a valuable feature or input into that system, where it's quite predictive of if a user is going to be approved or not. Credit score is a key aspect of that. And the way in which this centralized data set of features is created, the way it's maintained and built on, it really matters. So not only are you looking to build out this centralized feature store, but also the way in which it's built, is equally, if not more, important. All right, so the motivation for Borrowell behind our feature store, it allows us to kind of do 3 main things. 1, to accelerate the speed at which we can complete data science initiatives. We have a number of those kind of in production existing models that we need to retrain, as well as we need to support new model development. And this feature store allows us to kind of to tackle that. Second, it allows us to centralize and reuse previous data science work, as well as maintain the accuracy and the understanding of it. Having a feature store of machine learning features that we can keep up to date, really helps us, avoid, things going by, the wayside, after 2 or 3 years of not looking at something, it becomes kind of more legacy code. Having a feature store and having it centralized allows us to kind of maintain things as we go. And third, the feature store allows us to increase the visibility into data science work and the insights that come from it, and share those, across our organization. And to go a bit deeper into how we see the value of centralized machine learning features, back in the 2017 and 2018 days of Borrowell, we'd have 1 data scientist working on a training data set, and they're kind of building out the data set as they need for their data science problem. And then another data scientist across the company is also building their own training data set, in silo. And it's likely these 2 data sets are using the same features or similar features, but because of our kind of independent workflows, we're not really leveraging each other's kind of code and feature engineering in conjunction. We're doing everything kind of independently. Versus now, the world we've gotten to is, as we build one training data set of features, and we add a second one to it, there's all this kind of common ground between the training data sets, which we call the general features, that are kind of model agnostic and can be used across a number of different machine learning problems. And as we add a third data set to that, we can continue to leverage this general feature repository to keep building more and more training data sets from, to really help the efficiency of how we build machine learning training data sets. On the architecture side, we have kind of a number of raw data sources coming in, and this is the architecture for our entire feature store, and it kind of really starts with the raw data. So we have product telemetry, which is tracking when a user logs in, when a user clicks on things on our site, when they see financial products. All of these telemetry events flow through our raw data streams. We have user and credit data, user data like financial goals, and all of the credit data from our credit scores and credit reports, as well as transaction data. And this raw data flows through into our workflow management system, which is mainly using Airflow, dbt, and Bitbucket. So Airflow is our task scheduler, and it keeps kind of the automation components of our feature store up and running. dbt is our data transformation tool, and it's quite pivotal in our feature store construction, and I'll be talking a bit more about dbt later on. And third is Bitbucket, which is our source control, our Git system. So our workflow management transforms this raw data and sends it into our feature store database. This feature store database is housed within Snowflake, our kind of larger data warehouse. And within the feature store database, we have a number of different schemas. We have a general features schema, which has those model agnostic features that can be used across different data sets. And we have specific schemas to a data science problem like bill prediction or like approval chance. So these features are very specific to that data science problem. And also within these schemas, we have the target variables for bill prediction or for approval chance that we're trying to train the model off of and predict. And we use that data from the feature store database in a number of different ways, and a number of different outputs. One of them is we expose the feature store database to Looker, our BI tool, for data visualization purposes, for kind of feature exploration, to analyze the drift of features, all things like that. Second, we'll query the feature store to retrieve tabular data, CSV files that we store in Azure Blob Storage, and our Azure Databricks training pipelines for machine learning model training picks up these CSV files from Blob Storage to use them in the training job. And third, we'll kind of publish and pre-calculate features from the feature store and cache them in our Azure SQL database, our kind of production SQL database, which then is used for real-time prediction in production. All right, so I talked a bit about dbt. To give a quick kind of run through of how dbt supports a lot of these different pieces of our architecture. dbt is a data build tool, is an open source data transformation layer. And it enables data transformations by turning a select statement into a table or a view. So basically you'll have this select statement, which is querying data, and dbt will handle using that select statement to create a table. So it kind of handles all of the updates of data, the inference of data types, the writing of those tables. It kind of handles all of that, and all you need is this select statement to query data. And dbt has really helped us in the automation, the version control, and the documentation of our feature store. Specific to automation, when you have this select statement that produces the features you want, you'll pass that over to dbt, and dbt will build the actual tables in the database from that, which kind of really helps us in the automation area. All right, so key considerations when building out, a feature store, things we've kind of ran into and tried to tackle. There's kind of 6 main kind of categories here, and I'll jump into each of them one by one. All right, so automation. Bringing automation into your feature store process is really going to help you out. We've used infrastructure as code mainly at Borrowell, and for the feature store specifically, dbt has allowed us to kind of house our infrastructure as code. So our continuous integration and our continuous delivery process is defined with YAML pipelines. This really helps with our kind of our DevOps part of the feature store construction, and all of that is defined in YAML. When we update our source control of all of the feature store code, this is all housed in Bitbucket. When we update that with a merge, that update triggers our underlying tables in the feature store to also update with the latest copy of the code, whether it be like a change in the feature definition or feature calculation. That change in source control triggers the feature store to also update. And we also have Airflow, which schedules daily updates to the feature store data. So a quick kind of overview of what the pipeline looks like. We've got Bitbucket and Airflow, which both trigger Azure DevOps, which is our automation and deployment tool, which then orchestrates the rest of the pipeline. So Azure DevOps will then queue up dbt to either do a full build of all of these feature store tables or an incremental update of data. And that kind of full rebuild or incremental update will then update the Snowflake feature store itself. So that's kind of a quick overview of how the automation pipeline works. All right, so on the version control side, another kind of key aspect, key consideration for you building out a feature store. I always say get as much of your code into version control as you can. This will be the code you use to create feature store tables and to retrieve and engineer the features, as well as version controlling the metadata about features and the definitions. Getting this all in version control is going to help you keep track of what's changing. Did you change a definition or change a calculation, so you can look back on this and help debug if something were to happen. You have a lineage of all these changes in version control. Also, version control is going to help facilitate code review as well as peer review. So adding people into that process is going to encourage collaboration and get a lot of different inputs into how we should architect and develop the code for the feature store. And third, I mentioned a bit, this version control is going to give you the organization and the lineage of changes, so you can keep track of what's changed and what the impact of that was. A quick snapshot of what our version control looks like. So we use Bitbucket for version control, and this is a kind of a quick folder schema of our Bitbucket repository. You're looking at the general folder here, which has all of the general features, the model agnostic features that we use. Things like credit report features, user features, persona dimensions. And at the very bottom there's a YAML file that has descriptions about, essentially for all the features in this section. It lists like what the name of the feature is, what the description is, what the data type is, what the join keys are, like how to connect the data, and that really helps us on the documentation side as well. All right, another kind of main category, key consideration is to implement standards into your feature store. So having one location for things, having one repository, one database, and one programming language is going to help keep things central and standardized. You really want to avoid having multiple identical features in different places, or perhaps even kind of a more nightmare scenario is having very similar features in different places, or the same feature but a different naming convention. Keeping it all in one place, standardized and centralized, is going to help you maintain the accuracy and usability of it. Casing is another kind of main area. So we've implemented snake casing for feature naming convention. There's a lot of different kind of casing and naming convention methods out there. We went with a snake case, which is kind of a standard in Python for our feature names to help just keep things consistent. And lastly, having code standards. We've used SQL to build out our feature store. So we've had to kind of build out our own SQL code standard at Borrowell. But you're really looking for something kind of the equivalent of a PEP 8 for Python. So whatever programming language you decide to build your feature store in, implement a code standard, whether it's something already available out there or your own, to help kind of keep everyone's code looking similar, to help with the readability of it. And you can also strive for data quality. So keeping data clean will really kind of stem from the standards you set. So the naming conventions and the version control is going to help you keep your data clean. Keeping it accurate is definitely a challenge and a much bigger kind of undertaking. For our feature store, like the reuse of curated features allows us to reuse the previous QA that was done as well. So if someone's already done previous QA or anomaly detection on the features, all of that can be reused again, since we're kind of using the same features over and over. Also for accuracy, invest in your data engineering team. This is kind of more like kind of global, but data engineering really helps as a backbone to kind of keep the accuracy of your data. For data quality, keeping it available. We use Snowflake, our data warehouse, and it's accessible. We can go in and grab the data we need. Keeping the data up to date, we use Airflow to schedule daily updates, and keeping the data relevant and up to date is really important. And keeping it documented, so you don't lose track of things, and it helps people onboard into a new team. The documentation is very, very valuable, and we use dbt to tackle that. A quick kind of snapshot here. This is an example of a dbt YAML file. So you may have seen earlier in our Bitbucket repository, the general description YAML file talks about all of the different features. In this case, within the credit report features table in our feature store, it talks about the name of this table, like what's contained, as well as for each of the features within it, what's the definition of the feature, what's the data type, as well as a kind of a primary key to help you join this data to other sources. Another kind of key consideration is to give transparency, to make features explainable, and not all features need to be used by a machine learning model. So this transparency into features is going to allow you to find the one or two features that are predictive of the target variable you're training off of. And these features can be used directly with business rules as opposed to in an ML model. So this transparency into data can allow you to get the golden goose features a bit quicker, and you don't need to kind of train an entire ML model to capture them. As I mentioned earlier, we've exposed our feature store to our BI tool Looker to allow for this feature exploration and transparency. I'm a bit short on time here, so I'll kind of quickly run through these sections. So for transparency, this is a quick screenshot of what our feature store looks like in Looker. This is a quick visual of kind of looking at the relationship between precarity and how financially precarious our users are. That relationship it has on approval rate. If a user were to apply, will they get approved for a financial product? And this is kind of one example of how you can explore features in a BI tool to really kind of unlock the visualization of that feature. A second piece is to look at the drift of your features. This is looking at the average credit score of applications each month within our approval chance data set. And you'll see that the credit score is actually increasing over time. So you can get an idea of feature drift, how your features are changing over time here. One last key consideration is production feature serving. So we I've talked a lot about the training of data within our feature store, but serving them in production is a whole another thing. We've used our production Azure SQL database to serve features And we calculate some of these features on demand from our production SQL database. And those calculations leverage the same code as the feature store code. Other features are pre-calculated from the feature store and cached within our production SQL database. However, the cached features do have a timing lag. And we're always kind of balancing while querying kind of on-demand SQL features in production is more flexible, but it's also higher latency. So it's always a balancing act. And that's one of the things we're actually looking to tackle in a future iteration of the feature store. And the segue into what we're looking to tackle next, production feature serving is one of those items. So this is kind of the on-demand features that we calculate from our production SQL database takes up the majority of our service latency. And it's kind of really a balance of like, how do we balance the on-demand calculation, the flexibility of it with the latency that it incurs. So we are exploring some key value storage styles like document databases for future production feature serving. One other thing we're looking at for the future is data lineage. So how do you track SQL code changes? That's one thing we've done so far. But how do we track data changes? Tracking like what data has changed in the feature store, and what data has changed in our raw data tables that support the feature store. These things are often hidden from view and quite challenging to track. We're looking at things like Snowflake time travel, which allows you to take snapshots of your Snowflake data warehouse and compare them, as well as data validation snapshots in our training pipelines. And also, your BI tool can also be a way of keeping track of how data is changing. All right, so a bit short on time here, but I'll just want to kind of go through this one last section, which is how to kind of get started with your own feature store. So kind of recommendation is pick a language you want your feature store to live in, your feature retrieval and your feature engineering. This language could be SQL, Python, Scala. And once you've chosen that, stick with it to keep things consistent. And keep things simple. When you're first building out your feature store, you can look at leveraging your existing data store. If you have a SQL database or a kind of document databases, kind of stick with what you're kind of using today. Has really helped Borrowell. And maybe a bit of a preference. I find SQL can do a lot of heavy lifting. So SQL has been really valuable for our feature store construction. If you're on AWS, SageMaker has launched their own feature store system. So kind of worth taking a look at that. Start early and start small. Standardizing things early on and getting things into version control is really going to help. And derived tables for analytic purposes can also be a good starting point for feature store construction. And lastly, prioritize it, get the rest of your data science team on board. Features are key to any predictive model, and invest in them by building out a feature store. That is all I have. Thank you very much. And thanks to the entire Borrowell data team who helped with this presentation, as well as with the construction of our future store. Big thanks to you. And I'll take some questions, hopefully, with the 1 minute left here.
Yeah. Thanks, Dean. Thanks a lot. So I'll go through the questions. So one quick question from Fatima is is DBT?
Yeah, so DBT, it's more of a transformation layer. So it's not going to be like a programming language. It's going to kind of automate the construction of underlying tables. It's going to take me a while to get through all this, but yeah, it's more of a transformation layer.
Okay. Next question from Srikanth is, where do you get your transactional data from? Is it an external source or do you store it?
Yeah, so we have a bill tracking tool that tracks bank account transactions and bills, and we kind of operate with Amex is our transaction data provider. Yep.
Okay. Next question is from Agrita. She's asking, do you build features on transaction for each user? If so, are the features updated in the feature store for transaction? So how is that basically update happens?
How does the update of feature store data happen?
Yes, the transactional data.
Transactional. So our feature store is aggregating that data from other sources. So that transactional raw data is coming in to our Snowflake data warehouse, and the feature store is aggregating on top of it. In our situation, the transactional data is kind of handled in a document database style, and we actually write Snowflake SQL on top of that document database style.
Okay, thank you. So next question is from Anuja, what the process you follow to... Sorry, Dean, I don't know if you heard the question.
Sorry,
we lost you for some.
Okay, yeah. Sorry, yeah, just cut out there.
So how do you review the DBT code?
That
was the question.
Yeah, so all of our DBT code is published through Bitbucket, so it's all version controlled. Yep.
So it's like regular peer, right?
Yep.
Yeah.
Yep.
So there is a question from Fred. Have you ever had to develop a new feature that couldn't be easily written in C?
So often, if that's the case, it has happened. After kind of querying maybe the inputs, the different inputs of that feature in SQL, we'll do the final processing of it in Python. All of our microservice architecture for production is done in Python.
Okay, got it. So you basically it's a combination of SQL and Python, right? You can say.
Yeah, yeah.
Perfect, thank you. And then there is a question from Nigel. How do you monitor, track, and respond to data drift?
So yeah, that's a great question. This is certainly something we're investing more in and we're trying to tackle. I think the real win and what we're trying to get to is kind of automated, alerts when our data is, drifting. The model accuracy drift or feature drift happens. We want it to be an automated trigger.
Sorry, didn't at least I lost you. So can you please repeat?
Sorry, yeah. So for model drift and for feature drift, we're looking to set up automated alerts to capture that and to give us kind of warning signs. That's where we're heading, and we're looking to use our BI tool Looker to tackle that.
Okay, so next question is from Arian. I assume since you are working with financial data, you might leverage online learning techniques quite often. Is that right? If so, can you make few examples of the use cases?
Yes. So online learning is something we're looking at. We have our financial product recommender system is one possible area for online learning. We've been exploring some contextual bandit algorithms to help. In any problem where your feature set is changing frequently, the financial products you're predicting on are changing quickly, is an application for online learning, and that's one application we're looking at, but we're not there yet. It's kind of more at the exploration stage.
Okay, got it. So there is one more question from Mitchell. What is the next step for discoverability for your feature store? Discoverability.
So exposing the entire feature store to Looker is one big step. In terms of what's coming next, bringing more data validation steps into our Databricks training pipelines is one. And also kind of ensuring that all of the data validation steps are logged and into a model registry to keep track of what the model was trained on, what the accuracy data points were, what the feature kind of predictive value was. That's probably our next step for that.
I think that's it from all our audience, but I have one question. So at the end you said, right, the main next step is data lineage. And DBT, in the DBT docs, you can see the data lineage on all the DBT models. So is there any way you use any other lineage tool to get the data lineage from Snowflake to the BI tools or machine learning models? Like,
in terms of getting the data from the feature store to the BI tool, not sure if I understood, Mamta.
So basically, like, say example, if I want to do impact analysis and I'm changing any feature definition, what all machine learning models will be impacted, or what all Looker dashboards will be impacted?
Right.
So is there any lineage for that?
Yeah, so we don't have like automation in that area where like a change to the underlying feature calculation will kind of fall through to the rest of the systems. Currently, our kind of best practices is to like not change the features. And if you do need a new one, to add a new one if it is a different calculation, to avoid kind of problems downstream in BI tools and production systems.
Okay, thank you. Thanks a lot. Thanks, Dean. Thanks for such a great session, and thanks for answering all our questions.
No problem. Thank you, everyone. And thank you, Mamta. It was great.
Yeah, it was nice talking to you. And for everyone, if you want to make networking easier, you can update your profile on the right-hand corner at the top with your job title and company so that other can see you and help you networking. Thanks. Thanks, Dean.